Welcome to The Explainer. So think about the device you're watching this on right now. Every economic superpower in history has had one fundamental thing in common before they became incredibly rich, technologically advanced, or globally dominant, and that is, they built things. National wealth is historically built right on the back of manufacturing. And today, we're setting the stage for an unprecedented technological leapfrog that's happening right this second as India gears up to build the literal factory of the future. Britain's rise as a global power began with a shift from handmade textiles to factory-scale production. The US, Japan, and China followed the same trajectory, establishing a clear historical pattern. Industrial dominance is a necessary foundation for a global economic power. Henry Ford accelerated this process by perfecting the moving assembly line, which drastically reduced the time and cost required to build complex machines. His methods allowed the U.S. to scale its industrial output beyond any previous manual standard. This chart shows the manufacturing contribution to national GDP, and you can see India sitting at just around 17%. For comparison, advanced manufacturing economies like China routinely reach 28%. This lag is largely logistical. Indian manufacturing relies on thousands of fragmented, small-scale vendors operating in silos. They use distinct timelines and varying quality standards, which creates massive coordination bottlenecks for any large-scale project. To bridge this gap, India is attempting to bypass traditional factory models. The strategy involves applying the country's strength in software engineering directly to physical production, moving the sector toward an Industry 4.0 framework. For an enterprise operator or investor, the term Industry 4.0 is often too broad to be useful. Without a specific target, it's difficult to know where capital allocation will actually solve a bottleneck. This diagram of the Industry 4.0 tech stack provides a framework for evaluating where CapEx will yield the highest return. It breaks the ecosystem into 4 distinct layers based on the operational friction being solved. These represent a spectrum of trade-offs. The base tier focuses on rapid-scale facilitation to move parts faster, while the top tier focuses on deep tech specialization for high-margin precision. Successful modernization requires matching the specific layer of this tech stack to an organization's most critical operational bottleneck. Building a bridge or a solar plant requires coordinating thousands of independent, localized vendors. If a single supplier misses a deadline or delivers a batch of faulty steel, the entire project timeline is derailed. Zetwork occupies the base layer of the stack by acting as a digital aggregator for these fragmented suppliers. Using this layer means shifting procurement away from internal teams and onto a B2B marketplace. The platform uses data to find the most suitable suppliers, based on quality checks and referrals. This approach allows a company to bypass months of manual vendor vetting and source industrial components at scale. Zetwork already manages over 5,000 suppliers and handles roughly 15,900 crores in revenue. The trade-off is a loss of direct relationship control. While you gain the ability to coordinate across multiple countries through a single platform, you lose the individual leverage you would have with local subcontractors. The second layer of the stack focuses on the internal layout of the warehouse floor rather than the external supply chain. This is the physical automation layer, where Adverb provides hardware and software to manage inventory movement. Reaching this layer requires significant CapEx. You must map your facilities and deploy a fleet of autonomous mobile robots to move inventory without human intervention. The result is a massive increase in processing speed. These systems can sort thousands of packages every hour, effectively removing the labor bottlenecks that slow down e-commerce logistics. However, this investment is only practical for Tier 1 retail or national logistics brands. The financial cost and the disruption of retrofitting legacy facilities require immense operational scale to justify. Moving further up the stack, we find software-first overlays that can be applied to machines you already own. Infinite Uptime uses this layer to implement predictive maintenance, a system designed to catch mechanical issues before a breakdown occurs. Operators attach IoT sensors to critical gearboxes and motors to measure parameters like vibration and temperature in real time. AI models then analyze this data to recognize tiny patterns, like a bearing beginning to wear out. The system alerts factory managers weeks in advance, allowing for scheduled maintenance instead of a sudden stoppage. A second part of this layer involves quality assurance, which is the focus for startups like SwitchOn. They deploy industrial cameras and deep learning software to scan production lines for sub-millimeter defects. This replaces manual inspection with a continuous, high-speed digital audit. Layer 3 provides immediate OpEx savings with low integration hurdles. The drawback is that it makes the organization dependent on clean data transmission, and you still need a human workforce to perform the actual repairs the AI identifies. At the peak of the stack is deep tech precision, the most complex tier of modern manufacturing. Ethereal Machines operates here, focusing on components measured in microns, 1/100th the width of a human hair. This requires specialized CNC machining systems that combine high-precision hardware with real-time inspection software. The machine detects microscopic deviations and adjusts its process while it's still cutting the part. Perfecting this layer allows a country to build components for high-margin sectors like aerospace, defense, and medical technology, markets dominated by a few nations. The trade-off is a low-volume business model with long sales cycles and a need for a hyper-specialized workforce. It is difficult to scale quickly, but it builds a massive intellectual moat for the companies that succeed. Because each layer solves a different problem, your choice of technology depends entirely on your primary mandate. This decision tree maps the correct layer of the stack to your specific operational goal. If you are managing an aging factory and your goal is to stop wasting money on unplanned downtime, do not buy new robots. Layer 3 overlays like infinite uptime offer the fastest path to OpEx optimization. If you are building national infrastructure or massive logistics networks, you need the sheer throughput offered by Layer 1 marketplaces and Layer 2 physical automation. For those focused on building a long-term, defensible intellectual moat in advanced sectors, the priority is Layer 4 precision machines. Modernizing a factory involves the precise translation of physical operational friction into actionable software data. India is in a position to execute this playbook by merging its surplus of software engineering talent with its existing physical infrastructure deficit. In modern manufacturing, the advantage goes to those who can write the most efficient code to manage the physical assets inside the factory walls. So, we've looked at supply chain marketplaces, autonomous robots, predictive AI, microscopic precision, and real-time computer vision, all of which brings us to the ultimate question. With software and hardware finally merging in these unprecedented ways, is India destined to be the next global manufacturing superpower? These 5 startups are proving that by combining their historical software dominance with physical hardware, the factory of the future is literally being built right now. Thanks so much for joining me for this explainer, and as always, keep questioning what's possible.